As we saw in example 15.1, L'Hopital's rule can only be applied if we're talking about limits which return an indeterminate form of 0 over 0 or infinity over infinity. So anytime you try to take a limit and you get one of these two guys, then applying L'Hopital's rule is a good path forward. Let's review what L'Hopital's rule states. We can take the limit of a fraction, f of x divided by g of x, by just differentiating the top, differentiating the bottom, and then taking the limit. And if this gives me a real number, and if that gives me a real number, then I can make a conclusion. And of course, g prime of x cannot be 0 because we can't divide by 0. So let's see here. Here, we're trying to take the limit as x goes to 0 of 3x minus sine of x divided by x. So as always, our first attempt is just direct substitution. Here we get a 0 minus the sine value at 0 is also 0. So the numerator is 0, and then a 0 in our denominator. So we do have the indeterminate form 0 over 0. Our next step should be try to use L'Hopital's rule. So if we can get a limit out of this, then I can say that this equal sign is true. So L'Hopital's rule says to differentiate the numerator, which differentiates to 3 minus a cosine of x, and then differentiate the denominator, which differentiates to a 1, and then try to take the limit. So trying to send x to 0 now, we have 3 minus the cosine value at 0 is 1. So 3 minus 1 is a 2, 2 over 1 is a 2. So because we were actually able to recover a limit, that equal sign, the application of L'Hopital's rule, is valid, and the limit is equal to a 2. All right, let's try this again, maybe a little bit quicker. Trying to take the limit as x goes to 0 of this fraction. As always, our first attempt is direct substitution. This will be square root 1 minus 0 over 2 over a 0 squared. Our denominator is 0, and square root 1 minus 0 is 0. So we have the indeterminate form 0 over 0. Now our next attempt is going to see us differentiate the top, which will be 1/2, 1 plus x to the minus 1/2, minus a 0, minus a 1 over 2. And differentiating the denominator, we have a 2x. And I cannot forget my limit sign. Now let's try to take the limit, and if we're able to get something, we can claim that this is the limit. From direct substitution, 1 plus 0 is 1. The square root of 1 is 1. So we have a 1 over 2 minus a 1 over 2 over a 2 times a 0. That's a 0 over 0. Oh, we got the indeterminate form again. But this is the cool thing about L'Hopital's rule. We'll just try to do it again. Right? If we get an indeterminate form of 0 over 0, then by L'Hopital's rule, we can try to differentiate the numerator and differentiate the denominator. So by differentiating this again, we have minus 1/2 times a 1/2 times 1 plus x to the minus 3 over 2 minus a 0 over a 2. Now trying to, in fact, let's clean this up before we take the limit. Oops, sorry, that should read 1 plus x. Okay, now trying to directly substitute x to be 0, we get a minus 1 over 4 over a 2. That's a minus 1 over 4 times a 1 over 2, or a minus 1/8. So we were actually able to recover a limit by 2 applications of L'Hopital's rule. So the limit of this, we can say, is minus 1/8. And you can do L'Hopital's rule as many times as you get these 0 over 0 forms.